Okay, in this video we're going to talk about how to factor large polynomials, and we're going to use that synthetic division concept and that remainder theorem concept to do this. I want to point out first of all right now that I'm just doing this video for factors that are real. In other words, I'm not going to talk about any problems where the factors are complex with imaginary numbers. I'll handle that in a separate video. Okay? First thing I want to do though is talk about the difference between a zero and a factor. Okay? If you think about a polynomial function, remember polynomial functions have these waves in them like this. They bounce back and forth. And a zero is basically a value where it crosses the x-axis. It's an x-intercept. But I want you to be real clear about how zeros and factors relate to each other. If you have some big, long polynomial function, whatever it happens to be, and it graphs like this, if it has a zero at, let's say, x equals 2, and another 0 at x equals 3, and another 0 at -1, and another 0, how about down here at -3, well, the way that translates into factors is that if the function has a 0 at 2, then one of its factors is x minus 2. Because remember, you set factors equal to 0 to find out where the x-intercepts are. Well, if you set that equal to 0, you get positive 2. If it has a 0 at 3, one of its factors is x minus 3. If this is a 0, that means you got a factor of x plus 1. If this is a 0, you have a factor of x plus 3. So the number in the factor and the number that's the actual 0 or x-intercept are backwards. So keep that in mind, just remember that, because that concept will be kind of inferred throughout these lessons. Okay, so I want to say, take this function, 2x cubed minus 3x squared minus 5x plus 6. I know that k equals 1 is a 0 of this function. And my goal is to factor this thing. This is one of the problems in your homework. I want to factor this thing. So, if k equals 1 is a 0, that means that one of the factors of f of x is x minus 1. X minus 1 is a factor. Positive 1 is a 0. Okay? Now I want to figure out what the other factors are. So, here's how we're going to do that. I want to use synthetic division and figure out what I get as a remainder when I divide by positive 1. So there's 1. So I drop down the 2. You've done this a lot now. 2 times 1. Add. 1 times -1. Add. 1 times -6. Add. And we sure as heck better have a 0 there, because we were told that's a 0 of the function. It's a factor. There's a 0 remainder. All those things are interchangeable. A 0 remainder is a factor, is an x-intercept, or a quote-unquote 0. Okay, so that means that once I factor out the x minus 1, this is what I have left over. I start out with x to the third. That's 2x squared minus x minus 6. So I've partially factored it. Now I want to finish factoring. How does 2x squared minus x minus 6 factor? Well, hopefully that factors easily. If not, you might have to use the quadratic formula to figure out what the factors are. But we're hoping this factors easily. Let's see if it does. Do I use the trial and error method for factoring? Let's see. That would give me -4x plus 3x, which is -1x, and -6. So that would be the completely factored version of this. And you'll be watching a video pretty soon, and we'll do one that has some imaginary or some complex zeros. Okay? So that's how that works.